Good morning, my YouTube viewers. In this video, what we're going to talk about is experimental design, which is a part of statistics. So there's 6 steps that you need to follow in order to conduct an experimental design. And it's to define the research objective, number 1. Number 2, define research methodology. Number 3, conduct a literature review. Number 4, develop research design. Number 5, collect and analyze data. Number 6, present empirical findings. And so those are the 6 things that you must do in order to carry out experimental design. So what we're going to do in this video is experimental complete random design. And I've got a practice question to fill out for this complete random design. So it's going to be an ANOVA, that's an analysis of variance. And so you do an ANOVA when you have 3 or more samples that you want to test. So what we're going to do in this video, it's going to be crop yields. So you've got your yields for treatment hay being 4.2 to 6.1. You've got that's your crop yield. You've got your crop yield for treatment B, that's 4.1 to 6.1. And then you have your crop yield for treatment C being 4 to 4.8. So what we're going to do is we're going to do an ANOVA. We're going to do a single test of ANOVA, single factor ANOVA. So your F statistic tests for differences, and your p-value is the probability, which we have discussed in other videos. But basically what we're going to do, you're going to do an ANOVA single factor. So you're going to come over to data, and you're going to do data analysis, and going to do ANOVA single factor, and then you're going to follow all the directions. So that's going to be, it's going to be A2 to C6. This says before the D16, but it's going to be A2 to D6 to C6, or really A1. Really A1 to C6. It's going to be columns, and it's going to be labels, and you're going to have the alpha of 0.05, or you can select any alpha that you want. And then you're going to have the output range. So you can say where you want the output range to be. And in this instance, it is A9. And that's going to be your output range. And then you press OK, and then it carries out the ANOVA for you. But I'm not going to do the ANOVA a second time. And the reason why is because I've already done it. So this is your single factor ANOVA. And you've got your groups A, B, and C. You've got a count of 5 for A, B, and C. You've got your sum for A, B, and C. You've got your average for A, B, and C. And then you've got your variance. So you've got between groups, that's your sum of squares is 0.372. Your degree of freedom is 2. Your MS is 0.186. You've got your F statistic is 0.36. And your p-value is 0.699. And your F critical is 3.88. And then you have within groups, which is your sum of squares is 6.064, your degree of freedom is 12, your MS is 0.5, and then you have a total of sum of squares of 6.436, degree of freedom is 14, and but the thing that you're getting really interested the most in is your F statistic and your p-value. So your F statistic tests for differences, and your p-value is a probability. So although I haven't put it in here, but let's see what we've done. So what we'll do is we'll say your null statistic is no there's no significant difference between A, B, and C. And then you've got your alternate hypothesis. Okay, so and then you've got your alternate hypothesis of A, B, and C. So we've got our alpha. It's going to be 0.05. And then we're going to interpret it. And then so basically what happens when you interpret it is your p-value of 0.699 is greater than 0.05. So that means you're going to fail to reject the null hypothesis. But we're going to go ahead and do this the Excel way. So basically the interpretation is since the p-value is significantly greater than the alpha, then the interpretation is going to be that you're going to fail to reject the null hypothesis. And so what I've done is I have made a chart of the crop yields so you can see the crop yields for yourself. So you've got row 1 to 5, and then you've got treatment A, treatment B, and treatment C. And so that tells you what the crop yield is. And you can see that there's no significant difference between A, B, and C. So that concludes this video. In the next video, we're going to be talking about another experimental random design, and I hope you decide to watch it.